Hello everyone, I'm Frank, and welcome to Frank Puzzles, and this is today's very hard puzzle. So this was probably going to take a while. Um, Today's puzzle is called I Like Fun. And I do like fun, so hopefully this is fun too, aside from being a very hard puzzle. And it's by Gene and Sudoku. And here are the rules. Normal Sudoku rules apply. That is, each row and column and 3 by 3 region has to contain the digits from 1 to 9 once each. I've been toying with ways of putting it. Each row, column, and box has to contain the digits from 1 to 9 without repeats. I think I prefer that way, but maybe, I don't know. Um, that's a good way of putting it, actually. I like the way that they phrase that. Each row, column, and 3 by 3 region has to contain the digits from 1 to 9 without repeats, I would prefer, but because that clarifies things a lot. Anyways, then this is a special one rule which I've never seen before. Repeating Renban. Well, actually, I've seen it once, potentially toyed with, but it was never clarified whether we actually had to have a repeating whether we could have had a repeating Renban or not. It turned out that it didn't actually get a repeating Renban. But let's go to the actual rule here. For repeating Renban, the digits on a line form a consecutive set, but may be in any order. So that's typical Renban. But on this line, digits may repeat on a line, and the digit on the dot equals the number of distinct digits on that line. For example, a valid repeating Renban could read, excuse me, could read 3, 4, 5, 4, with the 3 being on the dot. So this is actually quite more restrictive, actually, because the digit on the dot is also saying that the actual is equal to the number of distinct digits on that line. So that's quite a bit more restrictive than the Renbans I was thinking of that could have potentially repeats on the line. Anyways, that's the rule set for repeating Renbans. And then we also have little killer, where digits along a marked diagonal sum to the total given. So therefore, these 4 digits must sum to 12. These 5 digits must sum to 13. These 4 digits must sum to 32, etc., etc. So as an example for this 15 little killer clue, we could have something along the lines of, say, 2, 2, 8, and 3. Because these 4 digits add up to 15. And that's all you need to have to solve to satisfy the little killer clue. You can have repeats along a diagonal for the little killer clues. And those are all the rules. I'm not sure what... Anyways, I was gonna say, I don't know. It doesn't look that hard, but maybe I'm underestimating it. Those are the rules. If you want to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. Let's start with the repeating Renbans. So on the repeating Renbans, what are the... You have to have at least 2 distinct digits here. So this is at least 2. You could have 3 or you could have 4 here. Similarly, this is 2. Can you ever have 1 distinct number on this Renban? No. So this is 2, 3, or 4 also. How many distinct numbers can you have here? You could have 6, because there's 6 total. So 1, 2, 3, 4, 5, 6, down to 3. So this is 3, 4, 5 over 6. right? Because you have 3 distinct digits here. So it could be down to 3 here. This is 1, 2, 3, 4, 5. So it's 3 to 5 here. This is 1, 2, 3, 4, 5, 6, 7, 8, 9. So you could have 9 to 3 here. This is 3 to 9, interestingly enough. Okay. The interesting ones are the 4 cells adding up to 32 and the 5 cells adding up to 13. Also, okay, so for the 2 through 4, if it's 2, the Renban has to be 2, 3, 2, 3 or 2, 1, 2, 1. If this is 2, this has to be 2 then. If it's 3 distinct digits, it's either 1, 2, 3, 2, 3, 4, or 3, 4, 5. If it's 4 distinct digits, it could be 4 through 7, 1 through 4, 2 through 5, 3 through 6, or 4 through 7. So this is at most 7 as possibilities. So therefore the same is here, right? This is the digits 1 through 7 as possibilities. If this is 6 distinct digits, this could be a lot. So it's really this 13 and this 12 that are interesting here. If this is 5 distinct digits, it could be up to 9. Let's look at this 12. This is at least 3. This is at least 1. So this could be up to 7 or 8, right? Okay, this is at least 3. This is at least 1. So these digits can be 1 through 7. Because this is 3 and 1 at least. That's 4. This is at least 8. So it could be 1 through 7 here also. Oh, interesting. Again, these two sets add up to 25. That includes the entirety of this repeating Renban line. So say we have the digits 4 through 9. What is the maximum this could be? The maximum it could be is 1 and 2 is 25 minus 1 and 2 and minus 1, which would be 21. Right? That's the maximum this could be, is 21. That could be the digits 1 through 6. So that could work. Can it be... Okay, so if it's 6 digits, it could be the digits 1 through 6. Oh, let's go similar here, right? What's the minimum this could be? So the maximum this could be, can it ever have a 7? No, it can't, because it would have to be 1 and 7 here. So that does not work. So this can never be 7 here because this is only 6 digits long, right? It can't be 6 here either. Actually, I guess it could be. It could technically be 6 here. It can never be 7 because the 7 would have to be with a 1. And that's only 6th in length for the repeating Renban. This plus this must equal 53. So it could be the full 9 here, because that's 45 plus 9. Sorry, 8. So 45 plus 8 equals 53. Oh, wait, but this is subtracting 1. So I guess this could be 1 and this could be 9. That would be a sum of 8. So it could be 9 distinct digits, and then subtract 1, and then add another 9. So that's possible. What about if it's 3? 3 doesn't seem likely. Because at most it would be 3, 4, 5, 3, 4, 5, and 3, 4, 5. So that would be 12 times 3, which is 36. Yeah, it's too small. Because you would have to subtract out at least a 3, 33, and then add a 9, which would be 42. So 3 cannot work here. What about 4? 4, you could have 4, 5, you could have 7 3 times, you could have 6 3 times, and you would have 5 twice at most. So that's the maximum value of that. Would be 7 times 3, 7 and 6 times added together times 3 is 13 times 3, which is 39, plus 5 times 2, and subtract out a 4, I guess. You just leave the 4 out. So 39 plus 10. So it could be 4. 4 actually could work here. Okay, so this is not as restrictive as I thought it was. This tends to be more restrictive here, which is interesting. Can... So this is at most a value of 21. So that would be 1 through 6 if this is 6. What about if it's 3? If it's 3, it could be 3, 4, 5, and 4. 3, 4, 5. Does that... Maybe let's try 5. What are the restrictions if it's 5? It cannot be 2, 3, 4, 5, 6. Right? At most. Because that's 20 plus another 2, which is 22. Which is already greater than the 21 it can be. So... if it's 6, it has to be 1 through 6. If it's 5, it has to be 1 through 5 with a repeat in there somewhere. If it's 4, it could be 2 through 5. Right? 2, 3, 4, 5 is 14. Plus like 2 and 2 is 18. It cannot be 4, 5, 3, 4, 5. Can it be 3, 4, 5, 6? That's no. So the only way you can have a 6 is by the 6 being here. So none of these can be 6. All of these have to be at most 5. Interesting. This can never be 7 here. If this is 7, that would mean these digits add up to 5. But this has to be at least 3, and these are at least 1 and 2, which add up to 6. So this can never be 7 here. We have 1 through 5 here. That's interesting. Hmm. This could certainly, though, be less than 21 with the 3 repeated digits, right? Hmm. Okay. So when can this ever be 6? So if this is 6, this has to, it cannot be 3. This actually has to be a 4. Because if you try to have 3 unique digits from starting from 3, you can only go to 3, 4, and 5. So this has to be 4. This means this is 5 or 7 here. This is 5 or 7 here. This would have to be 1 and 2. This would then be 3. So there's 3 unique digits. It's 1 and 2 specifically. So this is 1, 2, which forces this to be 3. This would be 1 or 2. This would be 1 or 2. Actually, it could be 3 also. And this looks like it works fine. Right? This is at most 8. That seems fun. This would have to be 5, interestingly enough. Hmm. So that seems to work fine. That's not a very big restriction there. It's because it could go down to 3. Okay, what if this is 6? Let's look at that scenario. If this is 6, we know this has to be 1, 2, 3, 4, 5 to add up to 21. These have to be 1 and 2. So this is 1 and 2, this is 1 and 2, which means none of these can be 1 or 2. This has to be 1. This is at least... Uh... Hmm. This can no longer be 7 or 6 here. So this couldn't be 1. This can never be 5 here. If this is 5, what can it be? This is at least 1, 6 and 1. So this could add up to 5 here. So it's 1, 4, or it's 2, 3. This has to be a 5 then, as one of those 3 cells. So this looks all kosher, actually. Hmm. Huh. Okay. Yeah. Oh, this can't be 1 or 2 here. Ah. Ah. Not possible. The reason we know it's not possible, all 5 of these digits are distinct, and they see this cell. These are in the same box, these are in the same row or column. And therefore, the digits 1 through 5 would eliminate all possibilities for that cell. So it cannot be 6 there. Okay, that's interesting. So this cannot be 6. Can it be 5? No, because the digits again cannot be 1 through, they would have to be 1 through 5. And 5 is already here. 1 through 4 have to be in these 5 digits, and it would eliminate all possibilities for that cell. So this cannot be 5 either. This could be 3 or 4 here, though. If this is 3 or 4, if this is 4, the 4 doesn't actually have to be in these 5 cells. So that would force this to be 4, interestingly enough. Same with the 3. If the 3 is here, the 3 doesn't have to be in these cells. And in addition, the 3... So if this is 4, it could be 2... The problem is it would have to be 2 through 5 or 1 through 4. And either way, those would all be here. But this could still be a 4, because none of these could be a 4, if possible, because we already have a 4 on the red band. If it's 3, you could actually choose 3 through 5 here, and then this would be 2, and that would work. Or you could choose 3, 2, 1, and this would be 4, and that would work. Interesting. So if this is 4, this would also have to be 4. Huh. Can this ever be... Well, it could be 2 if this is 3, and this becomes 3, 4, 5. Because that could be 3, and then this could be 5, and this could be 4. Or it could be 3, 5, and that's 4. Interesting. Um... Hmm. What are the minimums here? So this is minimum 4. You could have a 1 here, a 1 here, and a 3. So 4, 1, 1, 3 adds up to 9. So this is at maximum 7. Okay, that doesn't tell us very much. But if this was 7, this would have to be 1, 1, 3, and 4. The problem with that is neither of these could be 1. So this is at least 2, 2 here. I guess you could have a 1 here. So 7, 1, 2, 2, 1. That could actually add up to 13. This could be 3. That could be... actually, I don't know if that works. Okay, so 7, 3, 1, 1, 4. All right, this is 16. This is at minimum 1. This would be a minimum 2, 2, and 1. So that adds up to 13. This has to add up to 12. I guess. So this is at minimum 3, minimum 3, minimum 4. So this would be 4. Or this is minimum 4, right? You can't have a 1 here. Yeah, so that doesn't work. Because then this becomes 3, 3, 4, 4, because this has to have 4 unique digits, and that's 14. So you cannot have a 7 there. That's only specifically 7. Hmm. What other ways can you go about it? Okay. You can, if this is 3, you cannot have 2, 3, 4 be the set. It's either 1, 2, 3 or 3, 4, 5. Okay, what happens if it's 3, 4, 5? So if this is 3 and it's 3, 4, 5, this is 4, 5. That means this is 3, 4, 5, which means this is 2. So it's 2 and 1 or 2 and 3. Well, it has to be 2 and 1 specifically. So then this is 2, 1. None of these are 3. So we have a 4, 5, 4, 5 pair here, which makes this 3, which means none of these can be 3. This is a 4, 5, 4, 5 pair. This can't be 4, 5. This is at minimum, so this has to be a 4, because it's 3, 3, 4, 2. This would be 5. This can't be 4. It could be 3 or 5. This is at minimum 3 and 4. So at minimum, this would be 4, 3, 5, 4. Which I don't think works. This is 16 already, so no, it doesn't work. Okay, so 3, 4, 5 is ruled out as a possibility. 1, 2, 3 actually does work, though. So 1, 2, 3 works as a possibility. What about 4? If you have... So I think either way, this has to be a 4. If this is 3, it has to be 1, 2, 3 here. If this is 4, you have to have 2 and 3 be somewhere along these 5 digits. So this is always 4 then. Again, if this is 3, it cannot be 3, 4, 5. It can't be 2, 3, 4. It has to be 1, 2, 3 on this Renban, which eliminates 2 and 3 here. Because then this has to be 1, 2, and 3 specifically, which makes that 4. If this is 4, you always have to have 2 and 3 on one of these 5 cells, so therefore this must be 4. So either way, this is 4. Okay, so this is 4 either way, which means you have 4 unique digits. It must be 1 through 5, 4 through 7, 4 through 7, 3 through 6, 2 through 5, or 1 through 4. 4 cannot be here. Again, if this is 3, this has to be 1, 2, and 3 here. So this cannot be 4. Well, this can't be 4 either. This can't be 4. That's actually interesting. None of these can be 4. So what happens if this is 4? And say it's 2 through 5, right? Well... Okay, this can't be 4 here. If this is 4 and it's 2 through 5, this would have to be 2, 3, and 5. This would be 2, 3, and 5, and this would be 2, 3, and 5. So this is 10. This could be 14. This cannot be 2, 3, or 5 here. That's interesting. This is 4. So could either of these be 5 is kind of the question, right? This is 10. This is 14. 5 would add 5, and then you would have 2. So that could be 1, 1, 2. Possible. So possible. Yeah. Okay. So it could be. So either way, what do we know? If this is 3, it's 1, 2, 3 here. If it's 4, it's either 1, 2, 3 or it's 2, 3, 5. Either way, 2 and 3 both have to be here, right? If it's 3, it's 1, 2, 3. If it's 4, it could be 1, 2, 3 here or 2, 3, 5 here. So this can never be 2 or 3 because of the 2, 3, it has to be one of these 3. We don't know about this. Interesting. Um, oh, interesting here. This cannot be 9. If this is 9, the problem is these 4 digits cannot add up to 32. Because the only digits you could have is 5, 6, 7, 8 left. Oh, that's very interesting. Okay, yeah, what is the max? So, I don't know if going down this path makes sense necessarily, because there seems to be a hard cap here right now. We might have to visit this later. But what is this 32? This is at most 17. So these 2 digits add up to 15 at least. Therefore, this is 6, 7, 8, 9 at least. This is 6, 7, 8, 9 at least. Right? Because these add up to 15. This adds up to 9 and 9 at most. So therefore it's 18. And this would add up to 14 at least then. So this is at least 5 and 9. So this can never be 9. Can it be 8 unique digits? Maybe. If you have 8 unique digits, you could have 9, 9, 6, and 7 at most. Because you only have 1 duplicate in 8 unique digits. Right. So it's really this 32 that's the restrictive one again. So if you have 8 unique digits, you can only have 9 twice at most. You can't have another 8. So it would be 6, 7, which is 13, plus 9 and 9, which is 18. That would add up to 31. So you cannot have 8 either. Can you have 4? If you have 4, that means you only have 4, 5, 6, 7. So this would be 6 and 7 plus 7 and 7, which is not allowed. So this can't be 4 either. 5. 5 you could actually go up to 9. So that actually works decently. 7, you could actually have two duplicates. So it could be 9, 9, and 9, which is 27 plus 5 even. And that works. So it's 5, 6, or 7 here as the number of unique digits, or distinct digits. But if this is 5 through 9, I guess it could be, it can't be 5, 5, 5, 5. So it would require a 4. Or less. So that would mean it's 4 through 8 as the Renban. Could you have 8, 8, 8? 8, 8, 8 is 24. Plus you would need another 8, which is not possible. So 5 is not allowed either. If this is 5, again, you can't have 5, 5, 5 because this is already a 5 here. So this is, if you try to go 5 through 9 to accommodate the 32, this would have to be at least a 6. So it's 5, 6, 5, 5, which is already 21. Within one single digit is not allowed. So this can't be 5 either. If you have 6, that could actually work either way. If you have 7, it could work either way also. So this is 6 or 7 then. That's interesting. Okay, so this is at minimum 6113, which is 11. So this is at most 5. Okay, that's interesting. If you had 6, you always have to have a 9 here. You always have to have a 9 here. Right? Because if you only had an 8 at most, that would require all 4 of them to be 8, which is not allowed. So one of these has to be a 9. So if there are 6 distinct digits, it's 4 through 9, right? If there's 7 distinct digits, it's 3 through 9. So therefore, we know all of these are 3 through 9 here. You could have 3, 3, and 3. Can you? If it's 3, 3, 3, the problem is you have no duplicates here. Right? You've taken out all the duplicates of the 3, 3, and 3. So you need at least one 9 duplicate here. Right? Or you could have 8, 9 with 7, 8. You need at least one duplicate here. The easiest one would be 9 and 9, right? So say you had 8, 9. So 9 and 9 is 14. You had 8 and 6. This would be 7. So you could have 2 more duplicates here. And then another digit. So 3, 3, and 4. So that would be 17 at least. Which means this is at most a 4 here. Otherwise, this could be 6. You have 3 duplicates here is fine, right? Because you need only 1 here, and you have... Oh, no, you have 3 duplicates. No, okay. It would be one use of 4, and then 2 duplicates. So that's possible. And then we have another duplicate used as a 9 here, or as an 8. We just know we need a duplicate here. So if this is 4, 4, and 4 plus 6, that's 12 plus 6, which plus 3 works. So this is at most 1 through 4 here. That's interesting. I think that's the most we can get from these 2 arrows from this point right now. Okay, so then we have this again and this again. Okay, so there's that question, right? 7 cannot be here. We've proven that, right? Well, actually, just in general, it can't be there. Can this ever be 1, 2, and 3? Yes-ish. If this is 1, this then has to be... Okay, so then this has to be 2 and 3. Which makes this not 1. So this is 2, 3, 5, which makes this 4. This then can't be 1. And this can't be 2 or 3, so this must be 5. This is at minimum a 4. So I think this is already too big. So we have 4 and 5, 2 and 2 at minimum. Two and 2 at minimum. That's 9. That's already 13. Yep, too big. So we know this can never be 1. Interesting. So 5 has to be one of these 3. It could potentially be 4 through 7 still. But 5 definitely has to be one of these 3 digits. But they don't all see the same... Well, they all see these 2 digits, but that's not helpful. So we tried to have this being 4, 1, 2, 3. And that's the only way you could have 1 through 4 on this Renban. And that doesn't work. Because this diagonal is too big then. Okay. Interesting, okay. If this is 3, this has to become 1 and 2. This is 1, 2, and 3. And this is 1, 2, or 3. This becomes 5 then, which is interesting. What is this at minimum? Okay, so... let's go the other way, actually. Let's start with this. If this is 5, that means this is 3, this is 4. This does not have to be 3 here. This can't be 3 here. This just cannot be 5. So 3 has to be one of these 2. This is 3 digits. This is already 8, so this has to be 8, which means this is 1, 1, 6. This has to be 2 and 3 then, because there's 3 unique digits. So this is 3, this is 2, which makes that 1. This cannot be 1, so this is 2. This can't be 1 or 2, so this is 5, and that breaks. Because this is now a repeating Renban, which has to have 4 unique digits, but it's from 1 through 5. So... this cannot be 5. What if this is 4? That's interesting. If this is 4, this is 3. This has to be 5. This is at minimum 9, which is already too big. Right? This is 9. This would be 1, 1, 6 at minimum. So that would be 17. So this can't be 4 either. What if this is 3? If this is 3, this is 4, this is 5. Which requires this to be 1, 1. Right? This is 8. This is 6. This would have to be 2, and these would be 3 and 4. But these could not be 5. This can't be 2 or 3. This would have to be 1. So this would be a 1, 2, 3 triplet. But 1 is eliminated from both of those. So that doesn't work. So this can't be 3 either. Wow, there's a lot of restrictions here. So this has to be specifically 1 or 2 here. Huh. Interesting. Say this is 5 going up to... Actually, what are the minimums? Can this ever be 3? Going down to 1? I don't think so, actually, thinking about it. No, it cannot be. Because this has to be 3. So if this is 3, this forces this to be 3. One of these has to be 3. Ah, so this can never be 3 then. So this can never be 3. Because if this is 3, that forces one of these to be 3. But this 3 says there are 3 unique digits on this repeating Renban. But the 3, one of them has to be 3, which means one of these has to be a 3. So that doesn't work. This has to be 5. So this is 5, which means this can't be 5. This is 5 unique digits here. This adds up to, what is this at least, at most? This is at least 11. So these 3 digits must add up to 12 at least. Sorry, at most. Not 12. It already adds up to 11, so it's 5 at most. Which means you can only have 3 at most here. Right? 3, 1, and 1 potentially adds up to 16. So this is at most a 7 here. We need a 4, definitely. So 4 is either here or here. If we have, say, 3, 7, 6, and 4, that's already too big for 15, right? 4, 6, and 7 adds up to 17, which is already too big. So this is at least 4 here. This is at least a 4 here. What else is here? Can we have 6? You could potentially have 4 and 6 here. So one of these is 4, obviously. This cannot be 5. That's not helpful. This could be 4 and 6 here. So 5 cannot be on this Renban. 5 could be here or here. We don't know which. We know we need a 4 because this is at most a 3 here. There's a 3 on this Renban also. So say this was 3, right? Say if this is 3, this is 1, this is 1. Which means this cannot be 3. This has to be a 3. This can no longer be 3. This would have to be 3 then. This would be 2. This would be 1 and 2. This would be 1, 2, or 3. Can't be 1. This would be 2 or 3 here. 3, 3. This can no longer be 6. And in fact, it can't be... It has to specifically be 1 and 5. So this would be 1 and 5 here. That would be 2. This is possible. The question is, can it ever be 4 is the question here. If this is 4, then this can't be 4, so this must be 4. And okay, specifically, can it be 2, 3, 5 here is the kind of the question, right? Because if it could be 4 with 1, 2, 3, in either, or it's 3 with 1, 2, 3, in either way, that's 1, 2, 3, which is helpful. This is 2, 3, 2, 3. This can no longer be 3, so this is not 4. This can no longer be 3, because if that's 3, that forces this to be 3, which makes that 2, and that can't be 3. So this can't be 3 anymore, which means this is 2. One of these is 3. This can't be 3, so this must be a 3, which makes this 2, which makes that 3. Therefore, this can't be 3. It has to be 2 or 5, which means this can't be 2. This is 1. This can't be 2, so this is 1. This then could be 2 or 3 here. This is 4, 3. So this is 7. If this is 5, that doesn't work. So this has to be 2. This has to be 5. This is 4, 3, 2. So this would then be 3. This cannot be 5, so this would have to be 5, and this would be 6. This can't be 3 or 5. This would be 2, which would make this 2 or 3 not possible. So you cannot have 2, 3, and 5 here. It has to specifically be 1, 2, and 3. So this is always 1, 2, and 3. Which means this is always 1, 2, or 3 here. This is a 1, 2, 3 triplet here. Which means this is at least 4. So this is 4, 6, 7. It can't be 7. We know it can't get up to 7. So this is 4 or 6 here. Because of the 1, 2, 3 triplet in the row. This is 4 or this is 4. This has to be the digits 1 through 6. But cannot have a 5, and this can't be 4 here. That's interesting. If this is... I guess it could be. Okay, so what is this? You could have 1, 2 with 4 here. That would add up to 7. So this is at most 8. So this is 8 as a high. Let's mark that as an 8. We have a 1, 2, 3, 1, 2, 3 triplet here. So this cannot be 1, 2, or 3. These have to be the digits 5 through 9. But this can't be 5 here. Okay. These digits can never be 2, 3, or 4. They all see all the rest of the Renban here, and they have to contain 2, 3, or 4. So this can never be 2, 3, or 4. Interesting. Right? Because 4 sees both of all three of these. So this is 1, 5, 6, 7, 8, and 9. Where is the 2 in row 1? It has to be here. So this is 2, which means this can't be 2. Where is the 3 in row 1? It has to be here. And where is the 4 in row 1? It has to be here. So this has to be 2, which means this cannot be 3. So this can't be 2. This cannot be 2. So this is 3 or 4. This can't be 2. This can't be 3 anymore because we've lost 1 degree of freedom here. And by degrees of freedom, I'm talking about like what the minimum can go up to. Because this is 5 and 6 at least. 5, 6, and 2. So that's 13. This can be only adding up 1. So 3 has to be here, which means this can't be 3. This is 2. This has to be 3 or 4, because that's the only remaining digits possible here. 1 has to be here, because 1 cannot be here. Therefore, this can't be 1. It has to be 2, which makes that a 1. So this must not be 1. It has to be 3, 4, and 6. So 3, 4, and 6 adds up with 2 to add up to 15. So this is 1 again. 6 is one of these two, so this cannot be 6 here. So one of these has to be a 6 in row 1. This can't be 6. This can't be 6. This can't be 1 or 2. This has to be 3, which means this can't be 3. These cannot be 3. And because there cannot be a 3 on this Renban, it has to be 4 through 7. This has to be 1 because of the 2 here, which makes that 3, which makes that 2. This can't be 3 because of the 3, 4 pair in the box. So this must be 1. So this adds up to 3. Therefore, these two must add up to 9. And 3 and 6 and 4 and 5 both add up to 9. This is 2, 1, 3, 3. So that's 9. So this has to be 4. So this is a 4. Okay, the remaining digits here are 6, 7, 8, 9. This is 4. Oh, this is at min. So this is 6. We know for certain this is 6. So these digits cannot contain a 3. But this is still relatively... You could have 4 and 5 here, right? 4, 5, 4, 4, 4, 4. That's 18. Oh, this cannot be 4 then. So this is 3 at most. So neither of these can be 3. This can't be 6. Where is the 6 in this Renban? It has to be here. So this is a 6, which means this is 3. So this is 3 unique digits. That adds up to 12. So this adds up to 12. This adds up to 13. This adds up to 16. This adds up to 15. So this is 6, which means neither of these can be 6. This 5, 7 pair, they have to be uniquely different. So this can't be 5 or 7, and this can't be 5 or 7, because they seize both of those cells. We know 4 has to be one of those two cells. So again, this could be 4, 6, 7, 8, 9, but it can't, or 5, but it can't be 6 here. This cannot be 3 anymore. This can't be 3. Interesting. This can't be 2. This can't be 1. If this is 4 unique digits, it has to be 4, 5, 6, 7. If it's 3 unique digits, 3 is not duplicated. This can't be 1. Interesting. Where are the 2s? Can't be 6. One of these is a 6. One of these is a 4. We have one of these is a... Okay, this can't be 3. Therefore, this is 4, which makes this 6, which makes this a 3. So this has to be a 4. None of these can be 6. Therefore, we have a 7, 8, 9 triplet in row 3 and box 2, which makes that a 6 and makes that a 5. So that makes that a 7. So this can no longer be 5 here. So 5 is one of these 3. This has to be 7, 8, or 9 here. This can't be 1. This can't be 6 here because of this 6. This can't be 4. Oh, okay. There we go. So this 4 means that this is at minimum 4, 4, and 6. So this is actually... I think it has to be that then. Right? This is at minimum 4, 4, 6. And that's the minimum here for 21. So this is 6, this is 4, this is 4. If you try to increase something, you can't decrease any other value. So this is 6. We have 2 duplicates already. We know there's another duplicate here. So this cannot be a duplicate here. And it cannot be a 6 as a duplicate, because that's too small to add up to 32. Can you ever have 5, 9? If you have 5, 9, you would have to have a 9 and a 9, but that's too many duplicates then. So this can never be 5 here. This then has to be 7, 8, and 9, as with the 7, 8, or 9 as a duplicate. Therefore, the 5 has to be here. So this is 5. That eliminates 5 from these cells. Also, 6 is eliminated from these cells. So if this were to be 4, well, it can't be 4 because we have a 4 here. So this is 3 with 1 duplicate. It cannot be 4 here. So if it can't be 7, so this has to be 2. So it's 2 with 2 as another duplicate, because that's the only duplicate that works. And it has to be 1 or 4 here. Okay, we have all... No, we don't have all the 4s. So 4 is one of these 2. 1 is one of these 2. What is this? 4 is here, 4 is here, 4 is here. 4 has to be one of these 2 cells, which means where is the 4 in box 5? It has to be here. So this is 4. This becomes 8 or 9, because it can't be 7. This is 7, 8, or 9. This adds up to 32. It could be 9, 9. It cannot be 9 duplicated. It has to be 8 duplicated here. Right? You have 7, 8, and 9, which is 24, which you need to have. And therefore you need 1 duplicate, and it has to be 8. Okay. This is 1. 2. Where's 2? In box 5. Can't be here, can't be here. It has to be one of these 2 cells, which means this is a 1, 2 pair. Where is 6? 6 cannot be here or here. So therefore 6 is here. 5 has to be one of these two cells. 7 has to be one of these two cells. So 7 has to be one of those two cells there. Remaining digits in row 4 are 5, 7, 8, and 9. Okay, 5, 7, 8, and 9, but this can't be 7. This can't be 5, so this is 7, 8, and 9. This is, we now have, and this is 5, 7, 8, and 9. We have a 7, 8, and 9 triplet in column 6, which eliminates 7, 8, and 9 the rest of the column. This can't be 7 because of these 7s. So this must be a 3. And this is also 5, 7, 8, 9. What about the 3s? 3 is one of these two cells. 3 cannot be here, cannot be here. It has to be here. So this is 3, which means 3 is one of these two cells here. 2 is one of these two cells, but it cannot be that one, so this must be a 2. And 2 cannot be here, so 2 must be one of these two cells. Can't be here because of that 2, so this is 2, which makes that 1, which makes that 2. We now have a decent amount of 1s. Yes, so 1 cannot be here, 1 can't be here, 1 has to be here. 1 then has to be one of these two cells here. This can't be 6 because of the 6 here. 1 is one of these two cells. 1 is one of, cannot be here or here, has to be one of these two, which means this can't be 1, which forces this to be the 1. This can't be 7. This is 5, 8, 9. This is 5, 8, or 9. This is 5, 7, 8, 9. Okay. 3s. We've done 4s. We've done 5. We have a 5, 7, 8, 9 quadruplet in column 7, which eliminates 5, 7, 8, and 9 in that column. So this must be 6. Well, where is the 6s in box 7? It has to be one of those two. Ah, this can't be 1 anymore. This must be 4. So therefore, none of these could be 4, which requires then this to be 4. This has to be 7, 8, or 9. We see, okay, all of these are 7, 8, and 9. So this cannot be 7, 8, or 9 here. So this specifically then has to be 3 or 5, because those are the only digits remaining. What about 8? Can 8 be any of these? If this is 8, that eliminates 8s in 2 possibilities here, which is not allowed. Because we know 8 is the duplicate here. So 8 cannot be any of these cells, because if they are, they essentially eliminate 2 8s as a possibility. So one of these then is an 8. And either this was an 8 or this is an 8. We're not sure which one. Okay. These have to be 5, 8, or 9. 5s are not that limited, unfortunately. So 1 of 7 or 9 is here. That means the other 7 or 9 has to be one of these 3 cells. This could be 5, 7, 8, 9. This could be 5, 7, 8, 9. This is 3, 5, 7, 8, 9. And this is 1, potentially. This could be 3. And this could be 5, 7, 8, 9, unfortunately. That's still pretty broad. This can't be 5 here. This can't be 5. So this is specifically 1, 3, but 3 can't be here. and then 7, 8, 9 as possibilities. This cannot be 1, 3, or 7. Okay, well, that's helpful. So this can only be 8 or 9 here. Well, we have a 7, 8, 9 triplet in row 8, which eliminates 7, 8, and 9 from the rest of the row. So this can't be 7, 8, 9. This can't be 7, 8, or 9. So this is 1 or 3. 1 or 3. This is 5, 6, 8, 9. And that could still be 5, 6, 8, 9. This is 5, 6, 7, 8, 9. And it still could be any of those. Okay. So one of these is 5. That's not helpful. One of these 2 is 5. One of these 3 is 5. One of these 2 is 5. Hmm. Oh, these can't be 8 here again because... Okay, if this is 8, that means none of these could be 8. Which means that would be 8. Which would mean 8 cannot be here or here. So this cannot be 8. If this is 8, that would eliminate 8 here. So one of these 2 would be 8. So this 8 would eliminate 8 from being here or here. So this cannot be 8. Oh, this is kind of interesting. This is kind of a sort of Y-wing thing, but not quite. Huh. Very interesting. If this is 8, that means this has to be 8. Okay, that's interesting. So if this is 8, none of these could be 8, which would force this to be the 8 in the column. So therefore, neither of these could be 8, so therefore the 8 would have to be here, if that's the case. So if this is an 8, so say we made that an 8, that would mean none of these are 8, which would force this to be 8. Which would mean none of these 2 could be 8, so therefore that would have to be 8. Which means that couldn't be 8. So therefore this would have to be 8, obviously, and one of these 2 would be 8. Well, this could not be 8. This would have to be 8, which would force this to be 8. And then this would have to be forced to be 8. Which would force an 8 here, and then an 8 would be here. So that's if this is 8. If this is 8... I don't know what that means. That means none of... Okay, if this is 8, that means this cannot be 8. So one of these would have to be 8, which means this couldn't be 8. So this would have to be 8. And therefore, this would be 8. So those are the only possibilities for 8 here. Okay, so that's 8. This can't be 8. One of these 2 is 8. So then one of these 2 would be 8. So you have one of those two. Okay, so... And one of these two would be 8. One of these 3 would be 8. Okay, so this would be 8. One of these 3. One of these 2. So this would be 8. One of these 2 would be 8. One of these 2 would be 8. One of these 3 would be 8. And one of these would be 8. So every place else cannot have an 8. So this cannot be 8 here. These cannot be 8. And this cannot be 8. Oh, that's interesting. This can't be 8. This can't be 8. Hmm. Where is this digit? This digit, this digit cannot be here. Well, actually, no, it cannot be that digit. So these 2 digits are always the same, and these 2, well, okay, that's not always the same. If this is 7 or 9, the other one has to be here. This has to be, well, okay, no. This has to be 8. The other one has to be here. So it cannot be here. It cannot be here. It would have to be here. So one of these is yellow, no matter what. Well, if this is yellow, where can this yellow be? It has to be here anyways. So this is always an 8 or a 9. Because the other one has to be here, right? One of these 2. So if this is not 8, it's 9, that means this has to be the 9. This blue would be one of those 2, right? Because if it's not 8, that means this is also the not 8 one. And therefore, this would have to be a different one from here. It would be here. Oh, but that's not possible. So if this blue tried to be here, the problem is, where could it be in column 7? Can't be anywhere of these, can't be any of these, can't be any of 1, 2, or 3 because it's 7, 8, and 9. So this one has to be the correct blue. So this has to duplicate this, which means this has to be an 8. So these are all 8s, and therefore the yellow cannot be the yellow here. So it must be here, and therefore the yellow is a 9. These can't be 8s. This can't. We have a 7, 9, 7, 9 pair in column 1, which eliminates 7 and 9. So this must be 1. This must be 3, which makes that 1. This can't be 1 anymore. This actually has to be the same as the yellow. It's a 9. So this is a 9. This then has to be 7. This can't be 3 anymore, so this must be a 3. That's 3 in the corner. We celebrate because we know we're getting close to finishing this. This yellow cannot be the yellow anymore. So this is a 9, which makes this a 7, which makes that a 9. This must be a 6. So this is not the yellow. All the yellows are essentially incorrect. Well, this was actually yellow, so that is correct. So this is 9. This is 5. This is 6. This has to be a 7. No, it's 5 because of no 7 or 9. This can't be 5 or 9, so this is 7. This 9 means this can't be 9, so this is 7. This can't be 5, 8, or 9, so this is 7. There's no 8 here. This can't be 8, so this must be 9, which makes that 5, which makes that 9, which makes that 7. This can't be 7, 8, or 9, so this is 5. This can't be 7 or 9, so this is 5. This can't be 7, 8, or 9, so this is 7. This can't be 7, 8, or 9, so this is 5, which forces this to be a 9 and this to be a 7. And that's how you solve it. Oh, that last part was really cool, actually. It was the logic behind that. It was kind of like a Y-wing in normal Sudoku solving, but not quite because of the Renban restriction. That was actually really cool. Um, I would consider this hard, but not very hard. Um, it's in between. It definitely is in between. But if you just logic out everything, which some people would say is bifurcation, which is I don't know. I don't. You're gonna have to essentially do that sort of logic somewhere, which is essentially. That's why the whole bifurcation thing. I don't get the whole thing. I don't understand why people like worry so much about it because it seems like it's in order to solve this, how are you going to logic it out without essentially going down that path? You have to go down the path. There's no other way that you can solve this, right? And it still led to some really cool logic actually here. So this whole thing about it's bifurcation. What's like, you know what? Who cares, you know? It's an interesting way of solving something and it's actually fun. So why get in the way of people's fun? I don't know. Anyways, that was very cool. Very cool puzzle. Very nice results. I had fun, and I like fun. So I hope you like fun too, even if it involves bifurcation. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.